Hello everyone. So yesterday I discussed about one-dimensional array and I also explained this program, the average of 10 different total marks of 10 different students. So today I will explain about the searching linear search. Okay. So this topic, linear search, we have already discussed in your previous years. So in the previous years we had discussed about that topic and then the programs also. So it would be so you can refer to your previous year's textbook and then from there you can get a better understanding. Also this program is the same that is there in the previous year's textbook. Okay, so only thing is that they have changed the variable names. Okay, so the program to demonstrate linear search methods of elements in it. If you remember in the previous year's textbook, to find the position of a number of an element in the array, right? So the I'll just show you a pictorial diagram from previous year's one. So in linear search, what happens is that here the in an array, okay, so in each blocks the data are stored like this. So you can see that in a linear search, okay, the data are stored on a first come first basis, right? So if the first data is entered from the keyboard, so this data will be stored in the first block, that is the first array element. Okay, if suppose this array name is num, so num 0, right? Why? Because this the first array index starts with 0, so like that. So num1, num2, num3, num4, num5, num6, like that. Okay, so and again you observe that in a linear search, okay, the data or the values are stored in random order. That means they are not arranged in ascending or descending orders, right? So uh, this number is 12, this number is 6. So you can see that the data values are in random orders. All right. So in linear search, it is not necessary. That means in linear search, it's not necessary that the data should be in ascending or descending order. What we have to do is that we have to search for a particular value. Suppose like 55. Okay, using linear search program. So 55. Now what in linear search what happens is that when the program runs, okay, in linear search, the first this is the lowermost, this is the highest most, okay, element. So this is starting with 0 and suppose this is 10. Okay, so 10 elements. So here in linear search, to search for this value 55, the compiler will start searching from the first array element. 55 will be compared with 12. Is 55 equals to 12? No. If it is no, then it will move on to the next. Okay, and then it will be compared with this value. If it is not found, again it will go to this element. So in linear search, what happens is that starting from the first array element or the first array index, it will be compared with all these values until it encounters this number 55. Now if suppose you have a random number, this random number, and you are searching for suppose like 99, it will be compared with all of this number. If 99 is not found, okay, then it will return the result that 99 value is not found. Okay, so in that case you will not get the desired output. So here 55, so 1 2 3 4 5 6 7. So in array element 7, okay, or in index number 6, the value 55 will be found. So you can see that in linear search, sequentially the order of searching is done one after the other. Okay, now so that is in linear search. Now regarding this program, if you remember in your previous textbook, the to find the position value, so in linear search, this one, okay, so write a program to input an array num with 10 different integer values and search a particular value and its position in the array. Okay, so pretty much similar to that program. Okay, so I won't be explaining this program, okay, because I'm sure that most of you understood these programs in from the previous years. Okay, so what you have to do is that you type this program. Okay, you type this program, and before you type this program, first what you do is that you analyze this program. Okay, you analyze this program, uh, find out what are the variables declared, what is the size of the array, okay, what are the variables declared. For loop is essential, okay, and then you do a dry run method on it, after that, from the dry run method you make the table chart, okay, and then predict find out the output, how it is generated, and then after that you type this program and then you run this program and match it with your dry run method which you have built, okay. Then you will see, then you will get a much better understanding about how to solve this program, okay. Always remember the structure of the program, how it is built up, okay. So this is actually a very simple program. It looks complex, but it is a very simple program, okay. So using this program, it will show you how to do a linear search. Sequentially it will search for that particular value that you are entering. Like here, the range is given as 50, but it is not necessary that you have to enter 50 datas. The range is 50 means it will create 50 array elements, but not necessary that it will create 50 data values, that you have to enter 50 data values. It depends upon this, the number to be stored in the range, how many you are entering. If you are entering 10, it will create only 10 array elements starting from range 0 to range 9. Clear? Like that. So that, for that purpose, the variable n is created, okay. And when you have to enter the value, the for loop is necessary, right? There has to be a certain limitations, um, a certain condition, so that the loop will stop at a certain point. So that is by the counter. Here it is use ctr. We can use I also. I equal to 0, I is less than 9, right? So you enter the values 9 times. So based on that, you, if you want to enter 50, you can write here 50. If you want to enter 10, you can write here enter 10. So based on that, the loop will continue and you get to enter 10 times or 50 times, like that. So you have to understand the program concept like that, okay. Then after, what you have to do, you have to enter a search value. So this is taken care by this search variable. So what number are you searching from? The numbers that you have entered. If you have entered 10 values, so 10 values, let's say 1 to 10. Now which number are you going to search? Suppose you are searching for number 8, right? So that variable 8, that value 8 will be stored in this variable search, so that will be compared with the position value, okay. So initially position is assigned the value 0, right? So now that, so based on that, another for loop will be there. So now that every value starting from range 0 will be compared with the search value, that is range 0. What value have you stored in range 0? Suppose 1. 1 is equals to, so you have a relational operator comparison. 1 is equals to the search value, that is 8. Is it? No. Again, so this body of this for loop will not execute. Again the test condition, it will increment, and then again it will be tested. 1 is less than 9, right? Okay, so 2, what is stored in range 1? 2. 2 is equals to 8. No, so this will not be tested. So finally, when it comes to 8 is less than uh, 9, right? So 7 is less than 8. What is stored in range 7? Suppose 8 is stored. 8 equals to 8, because 8, the value 8 is stored in the variable search, right? 8 is equals to 8. Yes, so this position will be incremented by 0 plus 1, or 8 plus 1, 9, okay. Or suppose like 7 plus 1, 8. So that means when it reaches 7 is less than 9, okay. So here it will be 7 plus 1, 8, okay. So that will be compared with this if 8 is greater than 0, the position of the search element is, okay, so that value, that variable will be displayed 8, okay. Otherwise this cout statement will be executed, okay. So a very simple program actually from last year's only, okay. So what they've done is they've only changed the variable names and then the array name, like that. So same like last year's program concept only. So go through this program nicely, do a dry run method on that, and then after that you type this program, okay. Everyone, all of you type this program, and then uh, run this program and then check, find the answers. Okay, now if you do not understand this program, okay, you can always contact me, you can always message me, okay, so that I can make you better understand this program. Okay, now after this we will move on to the binary search. Now what is the difference between binary search and linear search? In binary search, okay, they use the method of divide and conquer. Okay, the whole element, okay, is divided into two parts, and then from there, out of those two parts it is split up, and then it is searched in the it is searched in half ways. So so here you have a pictorial diagram. Now let's say this is where the data, this is the block, array block, okay, where the numbers are stored. Like this is one block, this is array element 1 or index 0. So index 0, index 1, index 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. Okay, so let's say here there are 10 array elements or 10 data values starting from 1 to 10. Okay, starting from 1 to 10. Now what happened in binary search is you consider the lowest value and the highest value and the mid value. Okay, now in one thing you have to understand, it's very important that in binary search the data are sorted out. So the data are arranged in ascending order. Okay, in linear search the data are stored in random or random order. Ascending, descending does is it is not in ascending, it is not in descending. But in binary search it is very important that the data are sorted out and stored in from ascending order. So it will be 1 2 3 4 5 6 7 8 9 10. Clear? So now what we have to do is that the first value, that is 1, will be the lowest order number. The last value 10 will be the highest order number. Okay, and then how do we find the mid value? The mid value is found, okay, so the array element here will be 1, the index will be 0. Now it can be, the mid value can be found either with the array element number, that is 1, or the index number, that is 0, and then here it will be 9. Okay, so here in terms of element that will be 1 and this will be 10, right? So the formula is to find the mid value is low plus high divided by 2, that is 0 plus 9 divided by 2, or 1 plus 10 divided by 2. Okay, so 0 plus 9 divided by 2, so 2 4 8, right? Okay, so what will happen is that 4, so here, okay, either 4 or 5 can be considered as the mid value. Okay, so sometimes while dividing you may get decimal point values also, suppose like 4.5. In that case, okay, since decimal point values cannot be accepted, so you will consider the mid value as 4. Now why are we considering this mid value, and what is this low value, high value, and this mid value in binary search? Now in binary search what happens is that the numbers ranging from 1 to 10, suppose you are searching for the number 8. Okay, number 8. So what will happen is that to search for the number 8, since the numbers are arranged in from ascending order, in serial order, okay, from 1 to 10. So what will happen is that to search for that number 8, the in the unlike linear search, in linear search it will start from the first, it will go through all the numbers, right? But in binary search it does not need to search all the numbers, all the blocks. Okay, that means it does not need to search all the it does not need to compare with all the array elements. What it will do is that it will divide, if you are searching for 8, it will divide this numbers 1 to 10 into half. So let's say 5. Okay, so or let's say 4, 1 to 4, okay, and then 5 to 10. Now so this is the first half and this is the second half of the array. Okay, or this is the left part and this is the right part. Now what will happen is that, so here 8, 8 will be, so since 8, right, we are searching for the value 8, so most obviously that 8 will be, or let's say according to this diagram, okay, let's say you are searching for the value 3. So so since 3 is in this position, okay, so the left side of the array will be considered, and this side of the array will be totally ignored. So the compiler will totally will not search from this side of the array, that is starting from 5 6 7 8 9 10. It will be totally left out. So now the compiler only needs to search from 1 2 3 4 5 6. So that is why this mid value is very much important. Okay, this repeated processing keeps on repeatedly dividing, okay, by 2 will keep on going until you get the desired number, or until or till that number is not found, okay, till this division method gets reduced. So now what will happen is that you are searching for the number 3. So what will happen is that again this will, again a new row will be created. From there this will become the lowest values, that is 1, okay, and then number 4 will become the high value. Are you getting it? Okay, so now previously number 10 was the high value, but since we're considering the left part after dividing by 2, okay, so now the number 4, that is 1 2 3 4, the value 4 will become the high value, and 1 will become the lowest value. Again we'll do the division method. We'll find the mid between this high and low by this formula: low plus high divided by 2, that is 1 plus 4 divided by 2. So 5 divided by 2, 2 2, right? So now what will happen is that 1 2 3 4, right? So 2 will become the mid value. Okay, 2 will become the mid value, and then after comparing it with that value, again you will see that since 3 is not in this area, okay, in this area, so since 3 is greater than 3 is greater than the mid value, okay, so it will be always be compared with the mid value. 3 is greater than the mid value, then this side of the value will not be considered, so it has to lie within this area. Okay, again then it will get compressed. You will find it, in here again, uh, 3 will become the mid value, and then 4 will become the high value, and from there you will find out that 3 is found. Okay, so that number will, that position will be found, and then you'll get the answer. So that is how it does in binary search. Okay, so you have the numbers here like that, how it is found. Okay, just go through this, and then uh, regarding this program also, okay, type this program to the dry run method. Okay, so here what you'll see is that this is the function prototype. Okay, CLR screen, so it does not pass any argument or accept any parameters. Okay, so this is the function prototype. Here in the main function you can see that the variables are declared. Okay, so as per that, first last mid, okay, find search, and this is the function call. Okay, and so this function call, what it does is this, it will call this call function, and then it will execute this function body. Now here you can see that in the, as long as x is less than the value 25, the cout statement will be executed as /n, so it will move the cursor to the to 25 times, 25 lines, right? Now after that, okay, you have the go to function, go to xy function. Okay, these are the coordinates. This 0 represents the horizontal position, this 0 represents, the other 0 represents the vertical position. So what it does is same like that. Okay, it moves this cursor to the, based on this coordinate. So actually these functions are quite obsolete. Okay, so without this also it can run. So what is done is in this section you are entering the numbers, how many numbers you want to find. Here the range is given 50, just like in the previous program, but it is not necessary that you have to uh, enter 50 values, right? So that is determined by this enter total numbers in array. So here you are entering suppose 5 as per the program output, so that means you have to enter only 5 values, so which is by this for loop. So you are entering the value here, and using the cin output, the array elements will be created: range 0, range 1, range 2, range 3, range 4, right? Because 4 is less than 5. As long as 4 is less than 5, that condition is true, so it will be range 4 starting from range 0. So the values will be stored here, right? You get to enter the values. After that, what you have to do, immediately you will not execute the formula, because in binary search, the first thing what you have to do is that you have to sort out in ascending order, which is also, if you remember this part, uh, if you remember in the previous year's textbook, okay, Purple sort method, sorting it, right, to find the minimum maximum temperature. So go through that program in previous years also and compare it with that one. So if you remember the swapping method, right, okay, swapping method, in that textbook we use the variable temp, right? So this is also using the swapping method, and then uh, so go through this process. In this process, you see that you use the two for loops, that is the I and j, the counter variables I and j. Okay, so this is similar to what you have learned in the previous years, so go through that part. Okay, so this will sort out the values in ascending order. Okay, and then after that, the sorted values will be printed out. Okay, and then again you have to do the search, you have to search for that values. So this part is also in last year's program. Okay, so go through that. Okay, so uh, first do the dry run method, and then after that type this program. Okay, so if you do not understand this program, you can always message me. Okay, and then I'll explain this program for you. Okay, so type this program, though it looks difficult, but this is not a difficult program. Okay, so in order for better understanding, okay, I'll just explain this pattern, okay, so that you can understand how the binary search works out. Here you can see that you have to search out of this. So you can see that here the values are in sorted order: 3, 4, 7, 11, 18, 29, right, from ascending order. You have to search for the number 66 and 71. As you can see here, 66 is not present, but 71 is present here. But anyway, so how we have to search for 66? So you can see here, in the first step, lower is 1. That is, you in this case, in this textbook, it is taking the array element. This 3 will be stored in the first array element: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 89 will be stored in the number 10th array element. So here, lower value is 1, this is 3, and upper value is 10, which is 89. Okay, so now in binary search we have to find the mid value. So mid value is what? That is upper plus lower plus upper divided by 2, which is 1 plus 10 divided by 2, where you get the value 5.5. So since we do not accept decimal point numbers, so we take the integer value, that is 5. So what value is stored in array element number 5? That is 1, 2, 3, 4, 5, 18, right? So now 18 is the mid value. Okay, so in step 2, you get the mid value as 18, right? So now this 18 will be compared with the number 66. So 18 is less than 66, right? So since 18 is less than 66, that is the mid value. So this is the mid value. So this is the left side, this is the right side. Okay, so since 18 is less than 66, so that means since the numbers are in sorted order, ascending order, so the 66 does not need to be compared with these values, the leftmost. So now what will happen is that this side will be taken, the right part of the sorted array elements would be taken, and from there the search condition will begin, right? So now, since this is the mid value, so now in order to search for in the next step, what will happen is that we find the lower value next. So in order to find the lower value, the mid value is incremented by 1. That is, lower equals to mid plus 1. That is 5 plus 1, 6. Okay. So this becomes the lower value. So this was initially, this was the mid value. So now since we have to start searching from this area, so we have to find the new lower value. So in order to find a new lower value, we add the mid value by 1. So which means this is the sixth array element, that is number 6. So now we take the lower value as 6. Lower 6 here, it means the number position. Okay, 1 2 3 4 5 6. So 29 is 6. Okay, and then upper is 10 still. So we have to find the value between this 29 and 89. So now lower is 29 and upper is 89, or 6 and 10. Now we have to find the mid. So that is, mid is 6 plus 10 divided by 2, which becomes 8, right? So since this is 6 and this becomes 7 8, so 8 is 71, right? So 71. Now 71 will be compared with 66. So 71 is greater than 66, right? So that becomes, since 71 is greater than 66, so, oh yes, one thing, since this is the lower value now 29, and this is the upper value, and this is the mid, right? So this is one part and this is another part. So always we divide the searching array into two parts, the left part and the right part. Now since 71 is compared with 66, so, and 71 is found to be greater than 66, so now we have to search from the left part only. This right part will be totally ignored, because since 66 is less than 71, so no need to search on this side, because the numbers here are greater than 66, right? So only this left part will be searched, that is from between 29, 40, 45 and 71. Okay, so now what will happen is that 71 becomes the upper. Okay, so now in order to find the new upper, we reduce it by -1. Okay, so that is, what was the upper number? This is 8, this is 9 10, right? 8 minus 1, 7. Okay, so now this becomes the upper value, that is 45, that is the number 7. Okay, and then the lower value will be still retain the same number, that is 29. So now lower is 6 and upper is 7. Okay, so now to find the mid value between this 29 and 45, 6 and 7, we divide it by 6 plus 7 by 2, which is 6.5 is 6. So now lower becomes 6. Okay, sorry, mid becomes 6. So here lower is 6, uh, mid is 6, and upper is 7, 7, right? So now mid is 29. So 29 is greater than 66, right? 29 is greater than 66. So that means we should not consider this side, that is 29. So we have to consider this number. So that means lower is again incremented by, so we have to find the new step, right? New values. So again we have to find the lower position, that is 6 plus 1 7. So lower is now 7 and upper is also now 7. Okay, again when we find the mid value, that is 7 plus 7 is 7. So since we have to consider only one value, that is 45, right, the position, so now the lower is also 7, upper is also 7, mid is also 7, and in 7 you have the number 45. Okay, so 45 is less than 66, which is less than the number 66. Now after that, what happened is that since 45 is less than 66, we have to find the new lower position. So for that, lower is incremented by again 1, which is 7 plus 1 8. Okay, and in 8 position uh, we have upper position is 7, but the lower position is 8, which is not possible, right? So keep in mind that after finding the mid and we searching for a new lower position, okay, the upper position still remains at 7, right? That's why now it contradicts, lower is 8 and upper is 7. So what happens? The search becomes unsuccessful. Okay, so this way you can search for a binary using binary search, you can search for the numbers. Okay, so what happens is that you don't need to go through all the numbers share wise. Now this is just a small sorted arrays, right? So you're searching just out of 10 numbers, but you just imagine that if you have to search out of 1,000 values, in that case, do you think that linear search would be much better? Because in linear search, if you have to search for number 900, suppose 999, right, you have to start from 0, 1, 2, 3, 4, like that, right? But in terms of binary search, you will divide it. You have to, if you have to search for 999, you will divide from 0 to 1000 into two parts, right? So what will happen is that that will be so you can see that using the binary search, you can reduce the number of searches to be performed. Okay, so this is the ideal way of doing searching methods, okay, and sorting through the binary search methods. Okay, so I hope that you have understood. Okay, go through this nicely to understand much better. Okay, so that will be all for today.